The views and opinions in the following program remain those of the producer or sponsor, and not those of Medford Community Cablevision, its staff, management, board of directors, or other affiliates.
Hi, I'm Ron DeLucia, and you're watching Math Man, a program about math, try to make it a little bit interesting. We hit a potpourri of topics, and we try to answer some of the questions that you people call in with. We've had a couple of requests over the last month to touch upon a couple of topics, and we'll try to get most of them in tonight. But a couple of things. The program is brought to you because of the volunteers that come down and man the cameras, man the studio. If you're interested in learning how to do some of these things, please come on down. Dan Sano, the manager of the station, does a great job of educating people, and we have some equipment that goes beyond the cell phone or the little camera that you have at home. It'd be great for you guys to come down and learn how to use some of the equipment, because the people here will take time and they have the patience to work and train you and help you out. And perhaps you want to do a show. You can do a show about whatever you want. You might want to do a show about a wedding that a cousin of yours had. You may want to do a show about your dog or maybe your classroom at school. If you're interested in that, call the station and you'll get help. Okay? Tonight's topics are a few, but one of the things I want to talk about a little bit, math gets in all parts of our life, and it's going to play a big part in the election coming up. And how do I mean that? Well, you're hearing all these things about numbers and unemployment. Let's talk just a bit about unemployment numbers. Unemployment is hovering around 9%. And what does that really mean? Well, it means that approximately 9% of the workforce can't find work. Well, that number is phony. And all administrations use the wrong number. It doesn't take into consideration all the people that have stopped looking for work. And there are hundreds of thousands who have just given up and have stopped. It also doesn't take into account the underemployment, which means maybe you had someone who was a mechanical engineer and he got laid off from his job or the plant closed, and now he's working as a gardener or working at McDonald's, for $8 or $9 an hour. He's not used to that. His lifestyle was one that he made a lot more money, and now he's underemployed, but he's doing something to help feed his family. That's a tragedy, and those numbers aren't really reflected in the unemployment numbers that we hear. What is full employment? Well, full employment, like a lot of things, is not really full employment. If you're around 4%, you're considered full employment, because they figure 4% of the population doesn't want to work and isn't going to work anyways. So at 4%, there's a glut of jobs and far fewer people to fill the jobs. And what happens when that happens? People like me who own a company, or people like you will offer people more money to come work for you, and wages go up. When there's a glut of employees and not enough jobs, you'll see wages pretty much level off. And in some instances, I'm sure you know people, or maybe you've been unfortunate yourself, that you've had your income cut. I know people in the architectural firms that have had their payrolls cut, their payment 20%, because there's just not enough jobs to keep them employed. And they've decided, rather than lay off their fellow employees, they all took a little bit of pain and they spread it out. Now, we pay our taxes to help offset some of the problems that we have. But part of the problem is, where is the tax limit? We hear about the Buffett rule. Well, the Buffett rule, and Warren Buffett says, in fact, he said it this past week, that has been misinterpreted. He figures it should start around $10 million. If someone makes $10 million, they should pay a certain amount of money. Well, I don't know what that number is, but people have construed it as that if you make $250,000, you're rich. Well, maybe when we were in high school, or I was in high school, $250,000 was rich. When I started my career, and I graduated Lowell Tech, engineers had just cracked $10,000 a year. Camaros just cost $3,500. Now they're $50,000. Money doesn't buy what it used to buy, and we have to remember that numbers can be thrown around and numbers can be used incorrectly, and numbers can be used to shade an argument one way or the other. We have to pay attention to what all our politicians say and what they really mean. And we have to be good citizens, and we have to be able to decipher what they're really saying. One of the things that hit me was because there was a number involved. Elizabeth Warren said she was 1/32nd Cherokee Indian. Now, I heard today that someone did a background check on her, and there's no Indian blood in her. I don't know if there is or there isn't, and I really don't care. But the idea of what is 1/32nd of your being, whether it be white, black, Italian, Irish, or Indian. So let's figure out what 1/32nd really means. If this is a person, we have a mother and a father. We take half our genes from the mother, half from the father. Okay? So this person is 1/2 if one's black and one's white, 1/2 black, 1/2 white. We go up to the next level, and we have a person here, say a mother, a father, a mother, a father, and there are 4 people. And for one person to affect this, you're 1/4. If this person is, we'll say, blue, then you're 1/4 blue here, or you have blue eyes. Let's go up to the next level. And there are 8 things. So you are then 1/8. You're at you, your mother and father, your grandmother and grandfather, and your great-grandmother and grandfather. And if you go one beyond that, you can see that there are 16, so you are 1/16. So you have blue eyes. You're 1/16. And that's your great-great-grandparents. And, of course, one beyond that, you find out if you multiply by 2, you are 1/32nd. So if someone is 1/32nd anything, you've gone to great, 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 your great, great, great grandparents. One of them, in this case, she said, was a Cherokee Indian. At what point in time does this not really mean anything? Because if you go back in history, if you believe in the Bible, you believe in creation, somewhere along the line, we all started from the same thing or something. So if we're all related, what are we? We're one billionth of the same thing? I don't know, but I find that to be not that impressive. If you were a half Cherokee or you were half green, I think that would be important, or a quarter. But I think when you get up to dilution of 1/32nd, I think that's a little far-fetched. And I think they're just trying to do things. But this led me to think of what I wanted to do today. And I wanted to talk a little bit about probability. Now, probability touches our lives every day when we think of things to do. What are the chances are of something happening? Or that's not likely that's going to happen. We don't quantify it. We don't put a number to it. But we think it's not going to happen, or it's going to happen, or it's more likely not to happen. So let's put some numbers to some things which are common, and I'm sure we all do. If you're a gambler, then I'm sure this is going to be simple for you to understand. I'm not a gambler. I'm not lucky enough to be a gambler. I think I'd lose everything. So let's start with something very elementary. Let's just start with a coin with heads and tails. And you have 2 outcomes when you flip a coin. It's either going to be heads or tails. Yes, I know it could fall, on the edge and stand up, but that is so unlikely, and so the probability of that is so minuscule we don't even count it. So we have a heads, and we have a tails as an outcome. If you flip it up, there should be no difference in if it comes out a heads or it comes out tails. So the probability is 1/2 or 50%. Now, if you flip it one time and you get a heads, what's the probability of flipping it the next time and get a head? Well, the probability the next time is exactly the same. It's still 1/2 and 1/2 for another heads and another tails. Some people think because you had a heads or a tails the first time, it has an effect on the outcome the second time. And it doesn't. But if you want to relate the two and you say, what's the probability of getting heads the first time and then heads the second time, that's different. And the way we figure that is the probabilities are interrelated. They affect each other. So to get heads the first time, your probability is 1/2. To get heads the second time, the probability is half again. Now, you don't add those two together and the probability is a whole or 1. The probability is 1/2 times 1/2 or 1/4. So the probability of getting 2 heads is 1/4. Now, what's the probability of getting 2 tails? Is it different? No. It also should be 1/4. What's the probability of getting, in that combination, a heads and a tails? Well, you can do things visually, and a lot of times that helps. So let's go back here and make this a tails, and that's a heads. And we got 1/4 probability here, 1/4 probability there. No, let's get a tails, sorry. Now, if we wanted to make sure that we had a heads and a tails, you could have, it would come out 2 ways. It could come out heads, tails, or tails, heads. Each one of these probabilities is 1/4. Notice how they all add up to 1, because that's something that can happen. You have to have your outcome. So the probability of getting a heads and a tails in those 2 causes are 1/4 plus 1/4 or 1/2. Now, what would be the probability of getting heads first and then tails? The same as getting heads, heads, or tails, tails, because you're saying I want a specific outcome for a certain number of times, and it becomes limited. All right. Cards, I don't know if it's a lost art in the younger generation, but I grew up in South Medford, and we played cards all the time. We'd play whist on the corner, and literally there'd be 30 of us playing cards. So I grew up playing cards. I still like to play cards. And let's talk a little bit, about cards and independent outcomes. How about if I wanted to pick a card out of a deck, and I said I wanted to get the ace of spades? What are my odds, or what are my chances of picking that ace of spades out? All right? Well, I want to get a particular item. How many choices do I have? I have 52. So my odds of getting a specific card are 1/52. Little less than 2%. All right? Now, I pick a card. It's not the ace. I throw it away. I'm going to pick again. I'm still trying to get 1 card. So the odds, 1 card. How many possibilities are there? Well, I had 52 cards. I got rid of 1. So now it's 51. If I try again, I'm still getting 1 card. And now there are 50 left. And that's exactly 2%. 1/50th is 2%. So the odds of getting a specific card, I should get that specific card approximately once every 50 times or so if I pick cards out of a deck. Now, does that mean you can guarantee that if you pick cards out 50 times, put the cards back in, and you pick it out, you're going to get it? No. But the probability is it should come out during that certain part of time. Now, I'm sure you've all played poker. So why is it that some people seem to win at poker and some people don't? Well, I want to say it's luck, because I don't have any and I don't win. But there are gamblers who do play cards or play poker have a certain innate ability to figure out what the odds are. And some of them, the real good ones, the professional ones, actually do figure out the odds. So let's take a couple of hands and see what the difference is. Let's say I have in my hand ace, king, queen, and jack of spades. Right? I have 4 cards that are dealt to me. And I'm hoping that I get, what? 10 of spades, of course. Right? And I have a royal straight flush. What's the probability of the next card being dealt to me is the 10 of spades? This is what we're looking for. 10 of spades. What's their probability? Well, I know there are other cards out on the table, but it doesn't matter, because those are just given out. And it could be the 10 of spades is there, or it could be it's coming up. Well, there are 52 cards in a deck. There are 4 gone. Right? So I'm going to be picking, the next card is 1. And let's see, 52, gone. This one is 1 out of 51, 1 out of 50, 1 out of 49. Those 4 cards are gone, and actually there are 47 cards left. Well, there are 48 cards left, I'm sorry, and we're going to get one of those cards. So to get the ace, the 10 of spades is 1 out of 48. Not very good odds. Right? But if you play poker, you know you can get other hands. So what else could happen? I could still have a decent hand by not getting the 10. And this is what gamblers think of. Well, how about if I wanted to get any, let's see, any spade? If I got any spade, I'd have a flush. Well, the 10 of spades could be a card I could get. 10, 9, 8, 7, 6, 5, 4, 3, or 2, 9. So if I'm not interested in getting the 10, to get any spade, it would be 9 out of 48. Certainly a better chance, but also a less powerful hand. What about if I wanted to get any 10? Well, how many 10s are there? There are 4 10s. The 48 cards. 4 to 48. And if we add them all up, having a hand like that, you're looking at, let's see, 4, 10. You're looking at 14 48s. A little more than 25%. So if you have a hand like that, you still might be able to get something that's decent, but certainly not to get a royal straight flush. What about something like 4 of a kind? Four of a kind, which is the same card. All deuces, all 4s, all 5s, all 6s, all 7s. Right? To get the first one, as cards are being dealt out, you have one shot out of 52. Right? So now you've got that card. What are the odds of you getting the second card as we'll say we're looking for a 7. What are your odds of getting a second 7? Well, it's still one card. One is gone, so now it's 51. You want to get a third one? It's 1 out of 50. And then a fourth one, it's 1 out of 49. Now, that says, okay, what do I do with that information? Well, let's change it to decimals. We did a program once about fractions and decimals, and decimals are a lot easier. 1/52 equals 0.0769. I'll just write these numbers down, then we'll come back to them. This represents the decimal. As a percentage, to get one card that you specifically want out of a deck, it's a little over 7.5%. Once that card is gone, to get another one, you've got a little less than 6%. If you've got 2 cards and you want your next card, the chances to get this are 4%. You move the decimal point 2 places over. And to get another one, it's 2%. Now, what does this all mean? Well, if you want to get 4 in a row, or 4 of a kind, each outcome is related to the other outcomes. And when the outcomes are related, the chances are harder for you to get it. So your number of probabilities should be smaller. And if you ever get confused if you should add something or multiply it, just think of it. If it's smaller, you look at your outcome. The only thing you can do with probabilities is add them or multiply them. If you add them and you get a bigger number, if we added these all together, you get a bigger number than what it should be. What it comes out to when you multiply those, and I took the liberty of doing this, that's the decimal point. And for decimals, tenths, hundreds, thousands, 10,000s, 100,000s, millions. There's 36 millionths to get 4 in a row. All right? Move it over here, and the percentage is that amount. It's hard to get 4 in a row. You're not going to get it very often. Okay. Let's do something. This is not a course in gambling. It's just a question of trying to stimulate you a little bit on how to use numbers. We have the baseball season now. We did a program on all the statistics for baseballs. And statistics can be good. They can be used properly. they can tell you something. For example, a pitcher who's winning a lot. You say, well, he's a great pitcher. Well, he might have had great run support, that every time he gets up there, for some reason, his team scores a lot of runs. Doesn't mean he's a good pitcher. ERA, earned run average, strikeouts, getting men out and when the bases are loaded. A lot of times there are these things that are subtleties about baseball that make it a wonderful, wonderful game. And I think the statistics in baseball are second to none. I know you football fans out there talk about yardage or percentages there, but I still want to stay with baseball. You've heard about the cliche of drawing to an inside straight. All right? 10, 9, 8, 7, 6. A straight is 5 cards in a row. What's the probability of picking up this 8? We want one card, one specific card. We have these 4 in our hands, and we want one. Well, there are 4 cards gone. How many are left? There are 52, 51, 50, 49. There are 48. 48. And that translates, let's see, 8 48s, yeah. How many 8s are there? There are 4. So we could get 4 8s. When we deal with numbers on the end, if we had everything in a row, we had numbers on the end, you're having twice the possibility of getting a number. All right, I didn't want to make the whole program about gambling or whatever because it's not my interest, but I did want to touch about something that does interest me, automobiles and mileage of cars. Now's the time, the summer season's coming on. This is when cars are bought more than any other time. And I wanted to talk about mileage and the idea of why buy a hybrid car. So let's say you have a car that's $24,000. And you have one that's $20,000. And these are pretty good numbers for the Civic Hybrid and the Civic. It usually costs about $4,000 to get more for the Civic Hybrid. And I want to drive 15,000 miles. The insurance companies like to use 12,000 miles as the average miles, but let's use 15,000 miles. And if we had a hybrid that got 50 miles to a gallon, and a car that got 40 or a car that got 30, what is the real payback and the difference here? Because the difference is $4,000 more you spend. And I've heard people say, I'm going to buy a new hybrid car, I'm going to buy a new car because it gets better mileage. Yes, it does, but is it really worth it? Right? So let's say you do 15,000 miles a year, 15 miles per gallon, 40 miles per gallon, or 30 miles per gallon. You would do 300 gallons of gas in your hybrid. You would use 375 with another car and 500 if you got 30. And the key for a lot of cars now, the smaller cars, is this 40 miles per gallon on the highway. The Hyundai gets it. The Chevy Cruze gets it. There are a lot of these small cars that are shooting for that 40 mile per gallon. So if gas was $3.50, which is low right now, what would it cost you for gas? Well, $1,050. Let's see. 1,003 and 1,750. So for a year, instead of getting 50 miles to a gallon, if you only got 40 miles, look at the difference. It's about $260 a year. At $260 a year, it takes an awful lot of years to make up that $4,000 difference. At 30 miles per gallon, which would be one of the heavier cars, it's $700. Well, it takes fewer years, but it's still quite an investment before it makes up the difference. And if you go up to $4, $5, or $6, at $4, the difference between a hybrid and a car that gets 30 miles to the gallon is about $800. At 40 miles to a gallon, the difference is about $300. The idea is hybrids can be good if, in fact, you need a car. But to go out and buy one just to get lower mileage is a waste of your money. Now, you can say you want to help the environment, but what's going to happen to all those batteries? We really don't know what it takes to make these batteries. You don't know. You hear a hybrid. Do you know the poisons that are created just to make these batteries? And how are they going to dispose of them? They say the hybrid batteries are supposed to go 150,000 miles. Yeah, well, they say a lot of things, these manufacturers. I don't know if they're going to go 150,000 miles. And what happens when the car starts to approach that and you try to sell it? Are you going to sell it to someone when you have 130,000 miles and they say, I only get 20,000 miles out of this battery pack that might cost $7,000 or $8,000 to replace? One of the better alternatives, in my opinion, is diesel. It gets tremendous mileage. And if they ever came out with a diesel hybrid, it would help out. Hybrids aren't pure electric. Some of them are. The Leaf is. The Volt isn't. And you hear mileage like 100 miles per gallon. But they're not taking into consideration what does it take to make the electricity. I think a better alternative would be diesel and even natural gas. We have an abundance of natural gas. It doesn't have the energy of gasoline, so you need more of it, but it's far cheaper. And if you heat your house with natural gas and your neighbor heats it with oil, you know the difference. I wanted to get into taxes a little bit with sales tax and how much we get paid for tax. Steve, if you could hit this over here, just this tax chart. I just copied this from some of the stuff that the IRS sends out, and it's just the tax rates for an individual person. And you can see that it's confusing. I have a sheet here, and we'll probably do another show. Maybe we'll do it with the money managers. But the tax code that we have, if it was simplified, it'd make it a lot simpler for everybody. Well, I hope your interest is piqued a little bit in probability. If you go on the web and you check out probability, you'll find a lot of information on the web, and it'll lead you to different sites, hopefully not the gambling sites, but we use probability all the time in manufacturing even for output to see how many pieces fail as how many pieces don't. But thank you for watching. My name is Ron DeLucia. You've seen The Math Man. Hope to see you again.